Welcome back my dear friends, a very good morning, good afternoon, good evening to all of you wherever you are in this part of the globe. And this is the DADM 3 course, which is data analysis and decision making 3 course on the NPTEL MOOC series. The total duration spread is basically 12 weeks and which basically contact hours is 30, which means each lecture which is 60 in total number is half an hour. And as you can see from the slide, this is the 49th lecture which is in the 10th week, and with the 50th lecture we will wrap up the 10th week. Again another 2 weeks will be left. So, after each week in each week you have basically 5 lectures of half an hour each, you take the assignment. You have already completed and taken 9 assignment. After the end of the 10th week you will take the 10th assignment, and after the completion of the totality of the course, which is 12 weeks, you will basically appear for the final examination. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, if you remember in the last 2 lectures, which was in the 47th and the 48th, I went into detailed explaining the branch and bound method for the integer programming problem. Now, it will be a little bit different type of problem, which is binary, that is 0 1 problem, point 1. Point number 2 is that in the first problem which we discussed in the 47th and the 48th lecture, it was purposefully taken, which I am again repeating, it was purposefully taken to be of 2 dimension in order to make our life simple and make them understand. While in this problem we will purposefully take it as a higher dimension in order to make things much better and clear. In the higher dimension case, how we will solve the branch and bound. Also, now an additional part would be there, that at each and every stage I will be discussing how the branches happen and highlighting. I will basically draw the whole diagram for the branch and bound at one go, but keep highlighting where I am at which stage and which direction I am going, such it will be easy for you to basically take 2 things: the macro view about the total branch and bound in the totality and what are the branches and how they are going, and also in the micro view where you are at that stage, considering what is the integer programming or the binary programming in this case, how the linear relaxation has happened and how you are going to proceed to solve the problem. Now, the procedures of solving the problem remain exactly as it is in the linear programming case, and we can basically consider that the solution techniques we have already considered in the linear programming in the simplex method will be utilized time and again. Concept of dual prices, slack, surplus, artificial variable, everything will be considered as it is, as we have discussed. Now, this is the branch and bound example number 2, but now the difference is 2, they are binary variables and we will draw the branch and bound at each stage, and it is of higher dimension. So, we want to basically solve a problem maximization of 9x1 plus 5x2 plus 6x3 plus 4x4, all are either 0 and 1, and the constraints are like this: 6x1 plus 3x2 plus 5x3 plus 2x4 is less than 10, which is the first constraint. The second constraint is x3 plus x4 is less than or equal to 1. So, there is no x1 and x2 in the second constraint. The third constraint, which does not have x2 and x4, is as follows: minus x1 plus x3 is less than or equal to 0, and the fourth constraint, which does not have x1 and x3, is as follows: minus x2 plus x4 is less than or equal to 0, and x1, x2, x3, x4 are all binary. Now, here the problem starts. Problem means the solution starts, how we proceed. The problem is there, we will solve it. First, as usual, we will basically relax the problem, make into a linear programming problem. So, what happens? In the LP relax formulation, now here it is important to note that in each and every stage they would come out to be a different formulation, but the general concept remains the same. Only as the 0 and 1 integers, some are included, some are excluded depending on which direction we are going in the branch and bound. The whole problem objective function constants, they will keep changing, but do not get confused. If I as I proceed, if I think I want to make it more explicit, I will basically write down in details in each and every slide, which I will keep adding as we proceed. So, the LP relax problem formulation is same maximization 9x1 plus 5x2. plus 6 x 3 plus 4 x 4 is the objective function. The constraints remain the same, which is 6 x 1 plus 3 x 2 plus 5 x 3 plus 2 x 4 is less than equal to 10, which is the first one. In the second constraint, you do not have x 1 and x 2. So, it is x 3 plus x 4 is less than equal to 1. In this third constraint, you do not have x 2 and x 4, it is minus x 1 plus 4 x 3 is less than equal to 0. And in the final constraint, which is the fourth one, you do not have x 1 and x 3, it is x 2 plus x 4 minus x 2 plus x 4 is less than equal to 0. And the relaxed concept is this: now x 1, x 2, x 3, x 4 are no more binary, they are continuous between 0 and 1, they can take any values. So, technically it was a 2 dimension, it would have been a square where the search space would have been. 3 dimension, it would have been a cube, and in the 4 dimension is basically a hypercube. There are basically 4 dimensions x 1, x 2, x 3, x 4, and the cube have the dimensions, that means the values are between 0 and 1. So, you solve it using any problem formulation, and the problem formulation, okay, it is like this. So, you have, let me check whether if I am able to do that, I will continue doing it as. So, when you solve, the solution is as this: it is 16.5 for z and the corresponding values are x 1 is 5 by 6. Technically, it is a linear programming problem. So, 5 by 6 is applicable there, not in the binary case. So, this is not done, not allowed. X 2 is 2, which is allowed, x 3 is 0, which is allowed, x 4 is 1, which is allowed. Now, technically what you would have done is that you would have basically taken, if you have followed the concept of the branch and bound, x 1 is 5 by 6. So, you would have taken 0 and 1 and proceeded accordingly. So, this is the general concept. Now comes the branch process. First, I will tell you I am drawing the whole branch process, but here I am going to highlight where I am. I again saying the macro picture will be given, the micro points will be highlighted where I am in this. Like hold the map of, say for example, New Delhi is given and where I am, I may be at Connaught Place, maybe at Dwarka, that will be highlighted, and then from where from Connaught Place how I am moving, that would basically be given by the branches. So, this is the whole map. Look at it very carefully. I am starting from the left, I am going to the right for the branches. I could have basically started, considering the analytical hierarchy process, I could have started from the top and then gone down. So, whichever it is fine. So, I will keep highlighting where I am by the green color, and from where I have come, I will basically be highlighting with the red color. So, red colors, I will highlight using the blue colors, let me use. So, I will use this concept, blue colors from where I have come, where I am, and it is green. So, I am going to start at the solution which is as it is. So, when I solve the problem, linear programming, remember my actual solution is this. I have solved it, I have the values of x 1 as 5 by 6, x 2 as 1, x 3 as 0, x 4 as 1, the z value 16.5. So, now I want to branch. Where do I branch? Remember I told that few minutes back. I will branch for the values of x 1 where x 1 is 0 or x 1 is 1. So, these are the branches. So, here is the blue one where I am starting. So, now I will change the color to green. So, I have already solved the linear programming problem, relaxed version. Now, I can take two direction. I can take the first path, the first branch, the second path, the second branch, and highlighting the points. The x 1 variable which was 5 by 6 is 0, x 2 variable, x 1 variable which was 5 by 6, now it is 1. Now, you may be asking that what if x 1 was 5 by 6 and x 3 was also a non-integer, then you will basically go x1 and then take the 2 branches of x3, x1 and again take the 2 branches of x3. So, you could have done it. So, it will be a little bit more intense in the branching, but you will basically follow the same procedure. So, I am here, I have solved the problem and then let us go proceed. Now, we consider branch number 1. We can go with the branches as I mentioned, if you remember x1 as 0 or x1 as 1, and now we are considering x1 is 0, that means we are going in this direction. So, this is the direction we are going. So, what is the problem? Now, interestingly, check here one thing. The actual problem formulation was 9x1 plus 5x2 plus 6x3 plus 4x4. So, if you check this, so I will write it down 9x1 plus 5x2. So, it is 9x1 6x3 So, if you see the objective function, it seems to be changed, it is not changed because x1 is 0. So, obviously, this will vanish, x2 is there because why x2 is here, x2 value is 1. So, it cannot vanish, so it has to be there. So, x2 is there, which is right, x3 is not there. Why it is not there? Go back, check, x3 value was 0. So, we have just eliminated it. We could have written it, but we are eliminating it, vanished. x4 was what? x4 was 1. So, it should be there and rightly it is there. So, this equation is exactly equal to the actual objective function which I have written. So, I told you there would be changes and how I write the objective function, but I will highlight at each every stage. So, I will erase this. So, the objective function part is clear. Now, let us come to the constraint. So, I will try to do that each and every stage. So, if it is very simple, I would not highlight it, you will understand, but I will try to go a little bit slow as I did for for the first problem in the branch and bound in the 47th and the 48th lecture. So, what are the constraints? 6x1 plus 3x2 plus 5x3 plus 2x4, 6352. So, it is like this. Let us see, x1 was 0. So, it is vanishes, fine, x2 is 1 which remains in the constant, which is fine, x3 is 0, it vanishes. So, it is fine, x4 is 1, it remains the constant, which is fine. So, this constraint and this constraint are also same. Now, I come to the other, there are 4 constraints. So, I will go one by one. Other constraints are x3 plus x4 is less than 1. So, x3 is 0, x4 is 1. So, 1 is less than 1, less than equal to 1 is does not make sense to write. So, we omit it. So, 1 is equal to 1, which is very simple to understand. What is the second constraint? Second constraint is x1 minus x1 plus x3 is less than equal to 1. So, x1 is 0, x3 is 0. So, 0 is less than equal to 0, which is also fine. So, what is the fourth constraint? Fourth constraint is minus x2 plus x4. So, x2 was basically considered as 1 and x4, it could have been 0 and 1, but here it is 1. So, x2 and x4 is plausible. So, that will come into one of the constraints. So, minus x2 plus x4 is 0. Is the fourth one which is true, second and third are gone, first one has been reduced in this form. Now, here you see only 2 variables because x1 is 0 as per the concept. Here we are in that branch, which is branch. I will be switching from slide to slide. So, please bear with me. So, this branch we are, the green highlighted arm, and x3 is 0, x2 and x1 are binary. So, technically they are binary, but we will solve them using the relaxed linear programming. That is what I keep highlighting at each every stage. So, here it is. We are in this branch where x1 is 0, problem formulation is maximization of 5x2 plus 4x4, you want to maximize. The first constraint remains, which is 3x2 plus 2x4 is less than 10. The second and third are not to be considered very simplistically, I have mentioned that. The fourth constraint remains, which is minus x2 plus x4 is less than or equal to 0. And now, as we bring the relaxed formulation, it becomes x2 is between 0 and 1 both inclusive continuous, x4 is between 0 and 1 both values inclusive continuous. This has been highlighted here. So, now we have the LP relaxed formulation of the branch where we have gone the first step. You solve it and the optimum solution comes out to be like this: z is 9, x1 is 0, x2 is 1, x3 is 0, x4 is 1. If you remember, x3 was already 0, so it continues to be 0, x4 was 1, it continues to be 1, x2 was basically 1 already, and x1 we have taken as one of the branches. So, this basically meets our criteria, that is a binary variables are there, decision variables, and the answer is 9. So, where are we? Let us see in the graph. Graph means the branch. So, now you remember I mentioned from where we come will be highlighted by blue, where we are will be highlighted by green. So, we have already come from here. We have taken this route and we are here. So, the blues would be we have already visited, let us consider that. So, now green one, there is no branches here, which is very simple, because all of the variables are binary, which is as per the norm of the problem, and the value is 9, which is fine. So, we have reached one of the bounds, and on the branches which is giving us a result. I will not use the word optimum feasible, it's obviously it is feasible, whether optimum we will check that later on. So, now you want to go in the other branches. So, other branches are how do we proceed? Because we have taken x1 as 0, so obviously the other branch would be x1 is equal to 1, because x1 was coming out to a value of 5 by 6, that is why we differentiate that into 1 and 0. So, now is the branch 2, actually should be the second part of branch 1, but I am mentioning as branch 2. So, branch 2 was actually 2 roots, which I am just highlighting, mention again, x1 is 0, x1 is 1, and we now consider x1 as 1. So, now as x1 is 1, the problem formulation objective function is like this: 9x1 plus 5x2 plus 6x3 plus 4x4 is the objective function. Now, if you see the 9 value is coming because x1 is 1, so obviously 9 into x1 is 9. Technically 5x2 is there, which is fine, x3 is 0, technically that we should have written the whole problem formulation, but I am writing it in a much more condensed form in order to highlight for where we are changing, why we are changing. So, it is 6x3. Now, x3 can definitely be 0 and 1, because now we are trying to relax it. Relax in the sense not from the point of view of linear programming relaxation. Relaxation means in which direction you are going, whether it is plausible or not. Then the last part of the objective function is 4x4, and what are the constraints? There are 4 constraints. The constraints go like this: 3x1, 3x2 plus, okay, I should basically highlight it. So, the constraints are 6x1 plus 3x2 plus 5x3 plus 2x4 is less than or equal to 10. So, 6x1, 6 into 1 is 1, it goes on to the right hand side, 10 minus 6 is 4, that is why it is 4. I will just highlight it, I will erase it later. And the other values of 3x2, which is the second term in the first constraint, plus 5x3 plus 2x4 remains, is less than or equal to 4. The second constraint, let me check, or let us check, x3 plus x4 is less than or equal to 1. So, it remains x3 plus x4 is less than or equal to 1. The third constraint was minus x1 plus x3 is less than or equal to 0. So, now x1 is basically 1. So, what it becomes? So, if I take minus 1 to the right hand side, so it becomes x3 is less than or equal to 1. So, x3 is less than or equal to 1, which is the third constraint. And finally, the fourth constraint, what it was? Let us check. Minus x2 plus x4 is less than or equal to 0. So, it will remain as it is, minus x2 plus x4 is less than or equal to 0. So, now here x1 is 1. So, it is it is fixed. So, it is not a decision variable. The other decision variables are x2, x3, x4, they are binary. In the actual problem formulation, we will relax it, do not worry. So, it is x3, x2, x3, x4 can be 0 and 1. Now, we will relax the problem, that means make it a linear programming. Objective function remains the same, the first constraint same means with respect to what we have just discussed. The first constraint remains the same, second constraint remain the same, third constraint remain the same, third constraint means x3 is less than or equal to 1, fourth constraint remains the same, which is minus x2 plus x4 is less than or equal to 1. Now, we relax it and make the variables as continuous between 0 and 1. So, they are as follows, which I will highlight. So, it is, so x2, x3, x4 are all between 0 and 1, both inclusive. So, we will basically try to solve the problem for a linear programming where x1 is fixed at 1 already there. So, it is out of the problem. And now it is technique, I am using the word, but it would not make sense much in trying to highlight, because we would not be able to draw the diagram. So, we are now basically solving a problem in the 3-dimensional case where it is x2, x3 and x4. So, this is the second branch on the bottom part, which I will just highlight. The optimum solution comes out to be z is equal to 16.2. x1 is 1 already, x2 is 0.8, which is in the linear case it is fine, not in the binary case is not fine. x3 is 0, which is fine, x4 is 0.8, which is not okay, because in the binary case it should be 0 and 1. So, let me check where we are in the micro and the macro scale, considering the overall branch and bound diagram. So, where we are, that I said I will highlight using green color, and which other areas we have already visited, we will highlight it by blue color. So, first we will highlight the blue part. We have already visited this. So, we have already visited this. We have already visited this because this is the area from where we started. So, now the green part, from where we came, actually this is green and this is the area where we are. So, that value z as it has highlighted is 16.2, and the corresponding values of x1 to x4 are 1, 0.8, 0, 0.8, and we will basically consider accordingly. Now, interestingly note down here, there are two values of x which are not binary. So, technically their branches would go into two stages. Why two stages? I am not going to highlight it anything, I will just mark it. So, if you consider, we would basically consider in this sequence x2 branched out into 0 and 1, which I have done here. Then later on x4 as also would be branched out. So, we will consider, technically we should consider it, and even if it is not marked, we will come to that later on. As we solve the problem, this will become clear. So, we are in this green region in the micro level, and the macro level graph is given, and we will basically solve it. So, this is a feasible point, and we will compare that with the other feasible point and check which is the optimum one. Now, we take the branches based on the fact that x2 point, which was basically 0.8, can be either 0 and 1. So, we will basically do it like follows. The branch 3 which you are going to consider. Okay. So, this was basically branch 1, this was branch 2, branch 3, branch 4 we will go, but technically they could have been mentioned as branch 1, 1A, 1B, 2A, 2B and so on and so forth, but I just wanted to highlight it accordingly. So, we are in the branch 3 stage. So, the branch 3 was basically is that we have gone into x 2 is equal to 0, and if x 2 is equal to 0 and the problem formulations are like x 1 is 1 already, x 2 is now 0, x 3 is 0, x 4 is what we have to consider is basically 0 and 1. So, this is the problem. So, now we want to maximize, and the maximization problem, let me write down the actual objective function, because that what I said I will be doing at each and every stage. 9564. So, let me go in this way. I am writing the objective function. So, x 1 is 1, why it is 1? Because x 1 is 1 in this branch with the second one which I mentioned. So, this remains as 9, fine. X 2 is 1, 0, so it vanishes, which is fine, it is not there. X 3 is 0, but we will consider that we are trying to branch, and x 4 is the branches we are going to take, which is not there. So, this will vanish. Now, the corresponding values are, and obviously, so this meets the criteria of the branch, the objective function, which is fine. And the constraints, I will highlight the constraints and then proceed further on. So, we are here. So, I will first highlight the constraints one at a time. The constraints are just highlight it, wait. So, this is 1. So, this is 6, and so 6 goes to the right hand side, 10 minus 6 is 4. X 2 is 0, vanishes, x 3 comes, x 4 vanishes. So, this is 5 x 3 is less than 4. What is the second constraint? X 3 x 4 is less than 1. So, x 3 plus x 4 is less than 1. So, x 3 is a binary one. So, it is equal to 1. So, obviously, it would not be considered. So, x 4 is not there, it would not be. So, based on that we proceed and write the overall problem formulation, and then we will go into the next branch accordingly. So, here where we are trying to basically go into the branches accordingly and consider x 2 as 0 or 1 and then solve the problems. So, we will proceed step by step. So, our macro picture is this, which we will solve, which we have already solved the blue part, we are in the green part we have already solved, and then as we proceed this greens becomes blues, and we will basically see which is fathomable, which are feasible, which are not feasible. And with this I will end the last but one lecture in the 10th week, and we will consider the 50th lecture in the 10th week and consider the detailed solution in further more analysis for this binary problem using the branch and bind method. Have a nice day and thank you very much.